Distinguished seminar speaker series. My name is Birsan Dönmez. For those of you who do not know me, I'm a professor in the Industrial Engineering Department, and I'm very pleased to introduce our seminar speaker for today, Albrecht Schmidt, who's a professor in the Computer Science Department at LMU Munich. He is joining us from Germany, so we do thank him for this presentation, but also making himself available at 8 p.m., basically 8 to 10 p.m. his time. He apparently was at Northern Finland as well as New Zealand this week, giving virtual talks. So in his research, Professor Schmidt investigates the inherent complexity of human-computer interaction in ubiquitous computing environments. And over the years, he worked on automotive user interfaces, tangible interaction, interactive public display systems, interaction with large high-resolution screens, and physiological interfaces. I actually met him through his work in automotive user interfaces. He co-founded one of our flagship conferences, the ACM conference in automotive user interfaces, where we have the opportunity to kind of get together and share ideas within the space. But he also co-founded another ACM conference, the Conference on Tangible and Embedded Interaction, and has also co-chaired several SIGCI conferences, is in the editorial board of ACM Tokai. He edits a forum in ACM Interactions and a column of human augmentation in IEEE Pervasive. So he's really one of our leaders who's very active in sharing basically research findings with broader audiences within our community. And in 2008, he was inducted to the ACM SIGCI Academy. Most recently, Professor Schmidt's research focused on how information technology can provide cognitive and perceptual support to amplify the human mind. And this seminar will elaborate on this exciting topic. I've gotten a sneak peek of this. It's really very engaging, so I'm very excited to have him. So before I pass the mic to him, just a reminder for those who have received the notice, or basically sharing information for those who have not, we will have a Zoom meeting after this that will start at 3:10 p.m. so that we can have conversations in a more informal setting with Professor Schmidt. This is going to be, this is open to everyone, but we want to make it really student focused. So I encourage all our students to attend, and Laura will share the link on in the chat box. So thank you very much, Albrecht, for joining us today.
Thank you, Birsan, for the kind introduction, and thank you for having me. I think the background is we planned already a year ago that I would be physically in Toronto at that time, but yeah, it didn't happen, and so I'm even more happy to have now the opportunity to speak to you, even if it's in a virtual setting. And I think it has also its advantages. We can be very quickly at different places. So what am I going to talk to you today? I talk about interactive human-centered artificial intelligence. And I will look at a definition which we have put out, really more to be challenged than having just the only one right definition. So I'm really looking forward to discuss this definition, and I will outline some research challenges. We talked earlier a little bit, and it seems it's quite an interesting set of backgrounds you bring to the table. And let me start with the first question that may seem quite far away, but I find it really, really important. Who is in control? And I think that's a question when we talk about artificial intelligence that always comes up. And I think it's just after lunch for you, and in order for you to not fall asleep, I would invite you to just use the chat and what comes to your mind? Who has decided what you believe? Who decides what you believe? Can you try to think of it? Don't be shy, use the chat, and I'm waiting a minute. Society is one of the comments. Who else has decided what you believe, what you know? School? Let me dig down on school a bit, and family. Who has decided what's taught in school? I think that's a tricky one. Who has decided what's taught in school? Government and cultural norms. So it's really an interesting question. I think this is very fundamental what we have here, because basically what we believe is a lot what we are. And I think the question how we come to believe the things around us is really fundamental when we talk about AI and the power of AI. And I have been in Germany in a committee where there was a discussion on reformulating a school curriculum. And at that point, I really realized how complex this is, how many people push to get their ideas in and not others. Subjects try to get something in. In the end, computer science didn't succeed to get something in because there were other stronger forces. But it was interesting to see, because it is very clear, if you get your ideas in front of people, you will make them believe. In what way? Obviously, we have choices. We cannot believe things, but the environment very much makes us who we are. And now the question is, how does this environment change once we have AI, once we have systems that show us things? And there are very simple things. 20 years back, a news editor decided what's on the front page. Now it's an algorithm and probably doing A/B testing. And I think this leads me to the next question. Who creates your reality? What is your reality? The reality you experience as a person. What factors go into this reality? If you think of your everyday life, your community, people you interact with, and I think at this moment, a lot of this is mediated by technology. And I just picked two things out of the chat. Somebody said observations, and somebody said the people I interact with. And if you take things like, be it Zoom, you can switch on a beautifier. It doesn't very well work on me, but I think you can change your appearance. In the real world, that's much harder. Our observations are very often now made not firsthand. So I think ask yourself what in world history, since you have been on this planet, you have seen in your own eyes. Who has met Donald Trump in person? Probably only a small set of us. So it's quite an interesting question how our reality is created. And if you look deeper down, a lot of your reality is perception that's technology mediated. So you see something, but you really don't see it directly. You see it because somebody has captured it with a camera, broadcasted it to you in real life. And so our perception is obviously something we as individuals have a say in, because that's what we perceive. But what we perceive is nowadays more and more technology mediated. And with the moving forward of artificial intelligence, we see more and more algorithms taking over what we see, and hence they create our reality. And if we look very closely, and we can go down a bit more in biology or human biology, a lot of our reality is created by our primary senses. So a lot what we expect as reality is what we see and hear. And this is for a good reason, because for some years, 10,000s of years, this was really what was our environment. But now we know, and we do a lot of research in our lab on using augmented reality. And I think if you look on screens, what you see is not necessarily real. And I think a lot of things you probably have seen over the last years, like deep fakes, etc., that's just happening now. So we have senses that we trust to give us reality. But now, because we have a lot of the things mediated through media, our senses may mislead us. So I think that's the first takeaway. Think about what creates your reality. And that's sort of from a perception perspective, from you as an individual, but also for you as a designer, as an engineer. Think what reality you create for people. because you inevitably change their reality. If you do a web page, if you do an online video, you create reality. And I think this is a very tricky question. I have an even more tricky question. Who controls you? What decisions do you take? What did you have for lunch today? Who has decided? Who has control over what you have for lunch? And obviously, sort of in our philosophy, you usually have this understanding that we have a free will. That's sort of the myself that comes. And I think we have a deep understanding that's myself. I had sort of PhD students who work in the area of pervasive advertising. So pervasive technologies like outdoor screens, etc. I have looked into, and I think if we would decide ourselves, if we would have complete free will, advertising would not make much sense. And so typically we make decisions in the space we see. And I think very often this is sort of due to things we have around, as you say, so things you bought at some point, but there's a higher level. And that's also in the chat, somebody saying it's our culture, it's how we are primed, it's our resource constraints, how much we can afford. And I think when we talk about control, very often we come to this picture at some point, cyborgs. And I think this is another one where I would like you to think a little bit, what makes a cyborg? And perhaps we start with another question. If you speak a second or third language, what would be the word cyborg? And then if you literally translate it back to English. I'm not sure if you probably some of you speak more than one language. So if you have this word cyborg, if you look, what would it be in your language if it exists? Because it doesn't exist very often. I think in German, we also use the English term. So the same in Spanish, somebody says, an electronic person. And I think that's an interesting one because it makes it more specific. In what language was this back and forth? If you could just put it in there that we get. Are there more from Chinese? And I think for me now the question, really, what makes you a cyborg? From when on are you a cyborg? Is there sort of, where is the point? And this has also to do with control very often. I think there is this comment we see now, it's basically cyborg doesn't have to do anything with integration. It's basically a clever use of tools, of technologies. Other people argue cyborg is only if it's integrated in your body. And I think I like the Chinese translation back and forth. This is sort of the more hints towards the digital, because I think one of the other things you can discuss, if you get an artificial hip, if you get an artificial knee, which a lot of old people have in sort of rich societies, does this make you a cyborg? If you get a tooth filling, does this make you a cyborg? And I think the interesting question is where technology enhances us. And this is also the definition I would go with. If I have a technology that enhances me, I would consider this a cyborg if the control is joined. If I have full control, I probably would not call it a cyborg. But this is something, there is, I rather like it as a discussion, this question, rather than telling you what a cyborg is. I think it's something, again, to reflect over time, because also what a cyborg is moving over time as we get more used to certain technologies. I think at the beginning, things like glasses we wear or contact lenses were pretty advanced. By now, this is sort of everyday stuff. But I will give you one more picture for thought. So your mobile phone may make you a cyborg. And I tell you something that probably only works in Germany, but you could try to translate this. So imagine you have 100 people in a space in town. How can you move them? And if I move them, this would be sort of taking control over them. And in Germany, it's very likely that it works if you send all of them a text message with a location 200 meters further and you tell them there is free beer. So people would move, and so you control them. And I think we see this on a lower level. If I send you a message, you're very likely to pick it up. And I had one PhD student, he looked into when do you pick up messages? And if I detect that you are bored and I send you something, you're much more likely to respond. So I can basically change people's behavior by just sending them text message. It's a technology that's pretty old. So the question is, how much control do we have over ourselves if we live in an environment that's very heavily technology based? And the technology basis is increasing. And I have here some examples on smart devices. So this is sort of an estimate from 2010, I think, or 2012, but it still holds. So the idea is at the moment you have probably 1 or 2 or 3 mobile phones, perhaps a smartwatch, but the number of devices per person is massively going up with smart light bulbs, a lot of things that are now coming to everyday homes. So basically the power the mobile phone has over you to take time of you, to take attention of you, a lot of devices will be competing for that attention. And we wrote about this a little bit more, that it is really a shift to software. And I think a lot of you are in industrial design, mechanical design, but what you probably experience even when you now go into the industry, that most of the things that have been purely mechanical 20 years ago become sort of hybrid. There is software in them, and software is used to get an advantage. We see this in cars, see this in other areas, and we see it sort of in a whole range of things, like in wearables, in clothing, in smart homes, smart cities, smart industry. So this is sort of, it comes out of the technologies mechanical engineering has developed, electrical engineering, and I think we had this development. There was mechanics, then electrical engineering came in, and that did not take mechanical engineering away. It basically just added another layer of complexity, the electric one. And then now if you go to now, it doesn't take, if you have an autonomous car, it doesn't take the mechanical engineering away. It doesn't take the electrics away you need to drive it, but it adds on top more software. And so the question here is, once we have a lot of devices that are around us that are smart, they will all compete for our attention. And I have here a picture that's a book from Paola Zuccotti. She's an artist and she takes pictures of things that people touch over a day. And you can have a look and you can guess what type of person that is, who it is, what gender, etc. And I sometimes joke a bit, this is a bit like the view Amazon has of me. So Amazon knows what I buy because I'm a lazy person and I live, typically if I'm sort of not at university, I live in the countryside. So the easiest shopping is Amazon. And so Amazon has this view of me. So they know a lot about me. Now imagine all of these objects are going to be interactive, all of them being smart. They know, the t-shirt knows when you have worn it, the shoes know how long you have walked with them, and so on. So what happens is all these objects will try to make decisions. They will have processing power in them. They will have some sort of intelligence in them. They will try to, compete for attention. They will try to make you do things. So perhaps a sports device tries to get you play with it, a musical instrument tries to get you play with it, etc. So this is something we really have to be aware. At the moment, even just a simple thing like a mobile phone makes us spend a lot of time. And I'm not sure when you had the last time something, when you got up, basically you were 2 hours on TikTok and you haven't really realized how quickly you forgot time. And if you look at now the Internet of Things, a lot of people are thinking at the moment how you create devices that are engaging, and we teach even that. But if you think for each of the devices to have this engaging, this is really exciting, this is cool. But what will happen if all of those devices want to be engaging? All of them compete for your time, for your attention. And basically in probably 20, 30, 40 years, when most of the devices will have some intelligence in them, they will impact every move of your life. And I think things like a door opens while another door stays closed, you're more likely to walk through the open door than opening the other ones. There are a lot of things we're just used to because we have learned this throughout life how to do it. And so the tricky thing is evolution is pretty slow. It's like this. We typically, when we see a picture, we think it's real. Even so, we know by using technologies we have now in things like Photoshop, it is not necessarily real. And imagine now we have things, typically we have an understanding how our environment is, about the stability of the environment. And a lot of those things will just go away with robotic objects, etc. But our brain is probably not really good at understanding this. Talking about the brain, let's quickly take one more topic because I need those three topics: control, smart devices, and intelligence in order to go into the definition. So what is intelligence? And I think if you look at human intelligence, there is a lot written in psychology, how we define it, how we measure it, but there is still always discussion how well this works and what we really measure. And if we take a very small part, in 1996, 1997, computers first time, or basically one computer, Deep Blue at a time, won against Garry Kasparov in chess. And at that time, it was a controversial victory. I think Garry Kasparov was not happy to have lost against the computer, and he felt this is not really right. But I think already 10 years later, it was very clear computers play stronger. And now 2020, who is the best chess player in the world? We're typically not talking about a computer. We're still talking about humans, even so they're very likely to lose against computers. And this is a bit similar to even the strongest runner on 100 meters is losing against a grandma on a motorcycle. But we are still sort of seeing what that person who runs 100 meters in under 10 seconds achieves. So I think that's the tricky thing. We have learned in the physical world to discriminate between machine performance, like I'm doing 40 kilometers in a car in less than an hour, a human being running a marathon in under 2 hours. That's a very different thing, and we don't compare them. And I think that's something we still have to learn to understand this difference between the human and the machine. And I think now for designing systems, designing smart systems, I find cyborg chess, some call it centaur chess, some call it freestyle chess, very inspirational. And the game is very, very simple. It's basically chess, but you play it with the assistance of a computer. And in sort of, there are also settings where you have a team of players that can have computing power that plays against another team with computing power. And that seems, people told, that seems really exciting, because you have sort of the computer to prevent you from making stupid moves, even having very clever moves, but you still have the human element. And I think for me, this is a picture, people seem to enjoy that. Can we build systems that are more like this? Not like the chess program that plays against a chess player and wins, rather something that's engaging and where we manage to have a joint performance of human and machine. But before we go there, I have another task for you. Imagine this picture. So you have a question. On one side, you have a human with augmentation. And here we take a very simple case. Imagine you have a human, let's make it very concrete, a first-year student at university with an iPad and internet connectivity. Here you have a human who is very, very well educated. Let's take somebody who's just finishing his PhD or her PhD in that field, but with no augmentation, okay? Now think of questions you can ask where this person with the augmentation has a clear advantage. That's the easy side. What questions can you ask that where this person who has an iPad and internet connectivity clearly outperforms a very well-educated person who doesn't have anything? Make it very concrete questions. What are very concrete questions a person on this side can easily? Facts, general knowledge. What else? You could really even put direct thing. historical dates. Now we make it a bit more tricky. The questions that Google can answer, and I like that one, but now try to think of what you could ask that person, which this person is not able to answer. Can you make an example of an application question? Because I think this is very, very difficult. I think a lot of you talk about conceptual things, about the meaning of life, and I'm not sure if you get more of the meaning of life of a computer or not. You should check out ELIZA, that's also sort of on the counseling side. Explain intuition behind the solution in a physics problem. I think there are things, many of them are very tricky. And now I make my setup even more tricky. Imagine you have here a first-year student in your favorite subject, and here you have the same first-year student with augmentation and here with no augmentation. What can this person answer better than the person on the same educational level with augmentation? Where will the person perform? You obviously you can ask everything. It's a good. So what? And I think that's the right point I want to get to. And I think this was just in the chat. Basically, we have to learn, and I think that's one of the key learning. Basically, this person could basically take the liberty to answer any question without augmentation. But this is really hard in realistic settings, especially also in company settings. When do you, and I think that brings me back to this chess thing. When do you believe the computer? When do you believe yourself? And I think basically if you have the augmentation, if you have the tablet with the internet connection, you can still decide by yourself. And so I think this question of when do humans outperform the machine and when not, that's a really tricky one. And I think you put really a great number of good points in there. But if you dig deeper, what you will realize, once the question is very concrete, it gets really hard to outperform somebody who has Google or an augmentation. And I think a lot of the questions that's like, what is your favorite color, etc., they are obviously sort of on a different level. But if you look for things that are also relevant in a company concept, the how are you feeling today, I think a computer could answer as good as a human one could argue. And I think we had this discussion on how are you feeling today. This is the question, can we detect this? And the answer is probably similarly good as you if we do basically the full analytics based on your vital signs, on what you experienced that day, etc. We probably can learn what makes a good day and not. But I think the question I find interesting is really how do we understand when we need augmentation and when do we not need augmentation? And this brings then the question I have here. What are cognitive and perceptual abilities that we can enhance? What are things we can make better? And what are cognitive and perceptual enhancements that are really hard, which we probably don't get? And I think this is an open point. I think this is something for a long discussion, because some people argue certain things. And I think this is something we could also take up in a discussion. And the goal coming out of this is designing human-machine systems that outperform humans as well as machines. And I give you an example of the car. It is basically, if you have an autonomous car that drives better than a human, you should probably not include a human in the loop. If you have a human that outperforms the car, you should not basically have the autonomous car. So what you want is something that's better than the autonomous car by itself and better as the human without the automation. And a lot of the key challenges that are in there are the intuitive cooperation between human and machine. And I think at the moment, a lot of people are fooled that this is only about machine learning. It's really about building intelligent systems, building about joint control. And this is not really new. A lot of this has its roots in whenever Bush, as we may think, early work on man-computer symbiosis, the augmented human act by Douglas Engelbart and later Mark Weiser. And augmented cognition is also something very much researched also from DARPA in that case, but now a lot of more researchers. And from a technology perspective, there are a lot of things happening. So we have the theoretical motivation coming out of psychology, extended mind, distributed cognition, collaborative knowledge and group cognition, use of space, external representation, but also the technical things that are happening. Like we have great sensing system, we have advances in AI, we have devices for presentation like augmented reality, virtual reality. So there's a lot that comes together at this point in time that allows us to create really artificial intelligence for humans. And we have put out a definition, as I said, more to be challenged rather than having the final truth. And it is on interactive human-centered artificial intelligence. And I read a definition: an interactive human-centered artificial intelligence is an artificial intelligence that enables interactive exploration and manipulation in real time and is designed with a clear purpose for human benefit while being transparent about who has control over data and algorithms. And that's a very broad definition, but it asks for very specific points. And we have taken out we have taken out a lot of these points into properties. We have defined 8 properties to really check if something is an interactive human-centered artificial intelligence. The first one is interaction can be done by individuals in real time, and they can manipulate algorithms, models, and data. And I think that's at the moment nearly with none of the things possible. We can see the impact of manipulation. So if we change the input, if we change the models, we can see in real time how things change, how the AI changes. For fast processes like recognition in a car, we can reduce the speed and we can allow interaction in order that we can intervene and manipulate. We allow interactive exploration on how specific decisions are made. So you can ask, why have you suggested this to me? And you can find out why this happened. The second page goes a bit more higher level. It's this question, and I think that the number 5 is one very critical. But you need to understand what benefits humans have from this artificial intelligence. If they don't have a benefit, we should not do it. It's just a waste of time. What risks do we create with the artificial intelligence? And then 7 and 8, that's especially in sort of company setup, in a setup where we have companies that have a lot of interests, important. Who is in control? Who has the control? Who has the power over the data, the models, and the algorithms? Who decides what algorithms are used, what data is used? And I think the 8th point is the last one. How do we make visible what data, what information, what knowledge was used to create the algorithm? And I think we have seen a lot of bias examples where algorithms treat one group of people different and worse. And very often that's because the data that was used had already this bias. So this is an important one to understand the bias. And we can now use these features to look at specific things. So if I look at my Facebook feed, I can think, is this an artificial, a human-centered artificial intelligence? No, it's not, because it has a lot of the properties not. I cannot manipulate in real time how my feed is created. I don't know what I would have to change to get another feed. I cannot interactively explore why exactly this one was shown. I have no real understanding who has control over what. Is it the advertiser? Is it the company? Is it somebody else? And I don't know what data they use. And I think you cannot only use just for an algorithm, but you could also use it for something. And I found this picture of a car I've seen it in real life when we had the automotive user interface, which Pearson was hosting some time back when we still could travel. And so you could really apply those same properties and see what would it take to make this an interactive human-centered artificial intelligence. And I think with this definition, I want to just sort of, challenge and see if how people respond to this. And I would hope that there is a discussion in the community in computer science, but also in the other subjects to really understand what it means to have an artificial intelligence we can interact with. I will now look at one more thing that links this to control. And for the control, there is one question we ask a lot: how can we understand what it does? And this is sort of what we see in computer science publications a lot. Some people argue, just publish the source code, that will be fine. But we know reading somebody else's source code is really hard, especially if you teach first-year computer science, it's a nightmare. And even first-year computer science students can write code you don't understand. So I guess this is not working for explainability. And the visualization of a network, what we see here, I would also argue to somebody who has not designed this neural network, he or she probably cannot understand much of it. What is really interesting, if we take property 8 of our definition, is if we tell who has knowledge, what the knowledge is, what the data is that was used, we get a better idea what happens. And there was this in 5 years back where Microsoft built this chatbot, and it became very quickly racist. And I think if you tell people, oh, this was trained on Reddit, then people immediately understood why it was racist. They didn't need to understand the algorithm. A second point that's important in here is the granularity of control. And I think I go again to the example of a car. In 2000, you had full control over parking. You could park your car exactly how you wanted it. 2010, you had sort of the assisted parking. 2020, you have automated parking. The question is now, have you lost control over parking? And I think if you ask end users, they would argue not. They just change the granularity of control. And I think this is a key. And now when we design systems, I think what we should keep in mind, we should rather design for agency and for delegation of control than full control. Because as we have more devices, we cannot control everything ourselves. And that's like in a company, if you move up, if you become CEO, you delegate control, but you typically have the ability to go down along the chain of command and take over control. And now the question is, how do we do this if there are too many devices? How do we do the control thing? And we have argued we should flip the interaction paradigm from direct manipulation, I manipulate all the things all the time, to something where we say, I have a system and I guess the system works most of the time very well. I don't have to do anything. So that the system will go into the right direction. The light will be nice. Only if I think the system is not doing what I want, then I do an intervention. So the idea is I have no need for interaction as long as everything goes to plan. And I can design systems that they will happily work without any user interaction. But at the same time, users should be able to interact. And we have defined a few principles for those intervention interfaces. And I will just pick out one or two. I think you should be able to predict what happens. And you should be able to communicate what interventions you have. And I give you one example. Usually when you are on a train, you don't need to ask the train driver to stop if you want to get up, except the village where I live. The train is only stopping on demand. You have to press a button. Usually people who don't live here will not press the button and the train will not stop because they don't understand that there is an option for intervention. And I think this is sort of something important to understand. If we design intervention interfaces, we have to give people the chance to know when they have to do an intervention, when they can do an intervention, and when they don't have to intervene. And I think the final one I want to talk is we should try to minimize the required attention. But this is also a risk. If we don't give attention, the automated process may take its way. And this leads us to something which gets closer to the end of the talk. If we leave the system in control, I jump somewhere else and we come back to the control. Can we predict the future? And you will see in a second that this is very much linked to each other. Can we predict where you go next, what you will order, what you will watch on Netflix, what life partner you're going to choose? And I think there is a saying that goes from the invention side to say the best way to predict the future is to create it. And I think if we now think of systems where you go next, your navigation system is telling you what you order next is basically whatever Google brings up when you search for pizza, what you will watch. Netflix has a big say in that, what they put on the front page. And if you use an app to find the person you want to get together with, their algorithm chooses who you have. And I think for this, we probably don't create people's futures, but we nudge them into the right direction. That brings us back to this question of control we had at the very beginning. And I'll show you another car example here. So if you go from Munich airport to our offices in Munich, there are probably 100 routes you can take through the inner city, which are basically, they take all roughly 40 minutes with no traffic and up to 2 hours with traffic. But there is none much better than the other. Which route do you take? People take the route Google tells them to take. And now you can imagine if there's a Starbucks on the way and it's 4 in the afternoon, you may stop there. So again, technologies tell us what to do. So by building streets, we decide where people go. By providing tools, we allow what people can do. And I think what tells us, you cannot not manipulate people's action. Whenever you build tools, whenever you build infrastructure, you will change what people do. And this is, in a way, the end of serendipity. So manipulation and intelligent existence are very close together. They are not far apart. What we have here, imagine I build an intelligent interface. The version 1 says, take the train at 12:17 from platform 6. Version 2 says, which train do you want to take? 12:17, platform 6, 45 minutes, or the bus, platform 3, 50 minutes. By just making this formulation, you will take this one. Here you feel the system tells you what to do. Here you feel you have the free choice. But very often in good interfaces, we feel the free choice, but we don't have it. And I think be careful now when you look at interfaces, you'll see there are things like this. And that's very well known from advertising, how to do that. So this is an interesting part that we may manipulate people very easily by fooling them in believing they believe they have a choice. And I think in the end, we may have much less randomness because the algorithm decides for you what is the best person to marry. And I think this is a question, do we want to go there or not? What do we want from the people who build these systems? How transparent do they have to be? And I think for watching a movie, that's not a big deal. But once you buy a flat, once you sort of get together with a person, these decisions are very major. And at the moment, we see them moving towards, the infrastructure. The infrastructure are algorithms. And this brings me to very close to the end. So it will be in the infrastructure. We'll have no choice really to opt out. And Winston Churchill said, we shape our buildings and thereafter they shape us. So we build buildings and they shape how we interact, what we do with each other. And I would argue we shape our intelligent infrastructures and thereafter they shape us. We implement the algorithms and after that, they decide what we eat, whom we meet, where we walk. And the question really is, who is we? Is we, or is we Google, is we Facebook? Who is we? And I think I argue we should be we. So there should be power to society to really shape the intelligent infrastructure. And I think every one of you as a designer has this power when you design systems to see how they shape us afterwards. And once it's in the infrastructure, you cannot really opt out. Finally, it is shaping our reality, and perception is shaping our reality. But perception is not something that can be separated from technologies. And I jump over this project. There is a lot written about it. And this is sort of getting to the final point. Human computer, human data, human machine interaction is really shaping how we see the world, because there's less and less we see directly, more and more we see mediated through technologies. And that puts me to my final slide. Is this really that we move into a new age, into the AI age? And if we look back, if you look into the Stone Age and the Bronze Age, it is usually not the invention of bronze, which is in the long term the interesting thing. That was the basis. Once bronze were there, the interesting thing is what people build with it. And I think that's where a lot of subjects comes in. Once we have the material, once we have AI, what is the shield looking like? What is the sword looking like? What is the cooking pan looking like? So it's not making more bronze. The interesting is, what can you make out of bronze? And here, it's not necessarily more AI algorithms. It's really the question, what can you do with the AI algorithms? And I think that's up to you in your career. And I think with this, I'm on the end. I just have one slide. I'm happy to show the funding agency, in particular, the European Union and the BMBF that fund a lot of our research. Thank you so much for listening and staying.
Well, thank you very much, Albrecht, for this really inspiring and thought-provoking talk. So we do have a few minutes for questions. No one has typed anything, but if you do raise your hand, then I think I should be able to see you, and I will let you ask your question. Is it Mark? Mark, do you have a question?
Yeah. Hi, Birsen.
Hi.
Yeah, so I guess I'm going to ask a fairly straightforward question. One of the problems with things like AI is the human factors people are obviously are often being dragged along in the wake of technology developments. And, I'm just wondering we've been talking about Fitts list and all kinds of sort of things about how we should work with automation for many years, but it seems like things just happen and human factors gets dragged along in the wake of all the technology development. Do you have any thought about how people in human factors can make their work more relevant?
I think this is something where I feel at the moment it's similar for HCI. We are trailing sort of the algorithms people. And I think in Europe, we have set up a big consortium with a lot of people really trying to create workshops, really getting the discussion going, because I think nobody really knows what happens, but I think human factors people are the ones who really understand how it impacts people. I think if you look back in history, human factors has studied this on a minute detail and it has grown. And I think we have to probably pick it up on a societal perspective. And I think human factors has not done that too well in my view. So basically, this has been much more in sociology, if you look at workplaces, etc. But I think at this point, it's not sociology, it's really a technological question where I think how we design those systems that have part automation, systems where we have a lot of things computer mediated. I think human factors has probably a big thing to say in how we design these systems on a company level, on a societal level, and I haven't seen too much research in that space. It is sort of much more on sort of the smaller scale.
Yes, thank you.
Great, thank you very much. So we're almost out of time, I guess. So thank you very much, Albrecht, again, for this amazing talk. And just a reminder to everyone, in 10 minutes, we have a Zoom meeting where you can ask your questions in person, showing yourself to Albrecht, and we can have a discussion. So I encourage you to attend, and Laura has posted the link. Right,
thank you so much.
And this does end our session for today.